Hi, everyone, and welcome to the NeuroNexus Podcast, where we take a deep dive with the researchers using our tools to push the fields of electrophysiology forward. For over 20 years, NeuroNexus has been a leading provider of silicon probes. In response to the evolving needs of the field, we've expanded into data acquisition systems, accessory instrumentation, and cutting-edge software, together supporting rigorous research featured in nearly 5,000 publications. In this show, we break down the science, the setup, and the real-world lab experiences that don't always make it into the publications. Whether you're a longtime NeuroNexus user or just getting started in electrophysiology, you'll find something useful, relatable, and inspiring in every conversation. So let's get into it.
So I guess before we even get into that, tell me a little bit about your experiments and the questions that you're asking, the paradigm that you have set up. A little bit of background.
So I'm mainly interested in tongue movement and how we control tongue movement. And my main task is to describe the behavioral or motor landscape of the tongue movement inside the mouse while you are eating, while you are drinking. And we're doing this in mouse, which is very challenging.
Yeah. Why is that challenging?
Because you cannot see the tongue of the mouse inside the mouse while eating or while drinking, right? That's very difficult. So most of the work, even during my PhD, what I did was like trying to understand like something like interceptive movement using the tongue, but the tongue is usually outside the mouth. So the tongue just projects out and then you can see it. But while it is inside the mouth, no one knows how actually it is operating, how the movement is being shaped. And to do this, I'm also combining. So this is the part which is the behavioral part, understanding how this tongue movement is generated, how it is organized, and then how it is coordinated with jaw, like when you open and close, when you breathe. So this is the very general framework, like basically tongue motor control and coordination with other behavior. And for in vivo electrophys, we need this, and optogenetics, we need this to basically go to the brainstem near the hypoglossal, which is the first order motor nuclei, and try to understand how these first order motor nuclei are actually controlling step by step at the millisecond scale the movement that is very complex inside the mouth.
So I'm sorry again, where in the brainstem are you recording?
So we are recording from hypoglossal nucleus.
Okay.
And so this is the brain cranial nucleus responsible for supplying neural inputs to the motor muscle of the tongue. So the tongue has a lot of muscles. Each muscle is supplied by some segment of the hypoglossal.
Interesting.
Yeah.
Okay. Neat. And so then in, I guess, a broader context, what is the relevance of quantifying the movement of the tongue while eating, drinking? It's really interesting.
Yeah. So imagine if you are eating, the main question is you can bite your tongue sometimes. You can suffocate, like if you are talking and trying to someone is like tickling you or something, the water comes into. So there are a lot of like generally speaking, understanding at the basic level, understanding how we coordinate these movements subconsciously without actually thinking about it is in itself is interesting. But then you can think of it also from perspective of like swallowing disorder, a lot of patients who have dysphagia. There is a lot of problem with coordination of the movement, like when this happened exactly relative to the patient trying to swallow like water or something. So it has some clinical aspect. But what the main driver of the project is really the pure basic understanding of how we can do this very, very basic function in a unconscious way without even thinking about it. So
very
that's the main thing.
And then recording down in the brainstem, that is not an easy task. How is that targeting that nucleus?
That's a bit hard. So in Ayman's lab, like at Salk, it's Azim Lab. I think they have been doing some recording from Cuniate, which is another brainstem nucleus responsible for, it's one of the main dorsal column nuclei. And they basically use some methods to record from the brainstem of the Cuniate. So we are trying to use we are talking with different people who are making flexible probes, which can bend and can have good resistance to motion artifacts, which is like the main issue here.
Yeah.
Yeah, like, so this is still being on process, so I wouldn't say like we are 100% doing it, but we can get definitely a lot of activity, and we can do some motion correction, and we can do it in awake mice, but it is not still at a very early stage. So I just started my postdoc, so 4 months into it, so
congratulations.
not years.
That's awesome.
Yeah.
And so then are you currently working in behaving animals or in anesthetized animals? I guess are you doing the recordings? You were talking about other people during the recordings.
So no, like, so right now we set up, so I just finished setting up the behavioral apparatus for like where we get the XDAC1 and other stuff. And this is mainly optimized for recording from the Cuniate and from the deep cerebellar nuclei. But sooner, like once I'm dividing the project into different phases, and once I finish this phase, which is just understanding the tongue motor space behaviorally, then we go to the recording. But every now and then I'm trying to implant electrode, check how it's going, and then like it's not like I'm doing it every day. My main focus right now is the behavioral part, and every now and then I go back and try to do the recording from the brainstem. But it is like my main task right now is the behavioral part. That's what is occupying my head.
Yeah.
But we have done deep cerebellar nuclei, awake animal, behaving animal. We have done some Cuniate, still not behaving fully, but it is undergoing. So these are the two things. These are other side projects I'm doing. So
yeah. Well, it sounds like you've got a lot going on. And then I couldn't tell from the email thread, but are you guys using NeuroNexus probes?
No. So that's we are using a different types of probes depending on the project. So most of the project that I came into in the lab, they were already using different types of probes. So they are using we are using Cambridge probes. We are using Atlas probes. We haven't tried the NeuroNexus one. I think someone in the lab tried them, but I'm not sure. But yeah, like we haven't tried this, and we have a lot of also custom made electrodes for this flexible electrodes.
Yeah.
So this is like all still in process.
Okay.
What about you? What are you doing? I didn't understand.
Yeah. So I'm an application scientist with NeuroNexus. This is a new position for me. I started about 3 months ago.
So like me.
Yep. Yep. And I finished my PhD in neuroscience last year, and I was doing in vivo electrophysiology in the locus coeruleus. So also spent some time down in the brainstem. Yeah. And
okay, that's nice.
Yeah, but they hired me, and I guess I don't know, I'm doing a lot of different things for them right now, but one thing that they really wanted me to take on was customer engagement. And so just like talking to people that are using our products and being able to figure out, the ways that they're optimizing them and then kind of the shortcomings, and then be able to take that back to our development teams to help implement it, because like having really recent experience being in lab at the bench doing the things, I feel the pain of a lot of things, and then being able to articulate that to our team to be able to make those changes.
That's very nice. That's very nice. Where did you do in California also, or?
No, so I did my PhD at the Medical University of South Carolina.
Okay, South Carolina. Okay.
Yeah.
Oh, okay. That's very interesting.
But yeah, so I love electrophysiology. I think that it's really interesting.
I
Um,
love the sound. I love the
yeah,
crackling sound of the spikes.
yeah, isn't
That's
isn't that
my,
yeah.
yeah.
And was I seeing in the email you were telling Aaron that the sound wasn't
Oh,
working as well?
oh, so like this is the okay. So when I was taught in vivo electrophysics,
Hmm.
one of the main thing, Jim, like the main person who were guiding me through, is that we usually when we are going through the brainstem to reach the unit or something, we
Hmm.
depend so much on the noise, like
Yeah,
hearing how the spikes. You
yeah.
can identify the
Yeah,
spikes
our
actually.
our ears are the
Yeah,
best pattern recognition tool to ever
exactly.
exist on this planet.
So we had a significant issue. I think the XDAC system that we had when we connected the audio output from the XDAC itself,
Hmm.
it has a terrible noise.
Yeah.
Like you cannot hear anything clearly. It is
Hmm.
very muffled. Like there is a lot of
Mm.
problems, and I think
Yeah.
you guys replicated it. Dylan replicated it, and
Hmm.
then I found by accident 2 days ago or something that you don't need at all to connect to the audio output, and you can use Radiens. I think you guys have you can read basically they convert the signal, I guess, into an audio, and then you
Hmm.
can just hear it from the computer speaker, which was like very satisfying for me because it's
Yeah.
very clean signal.
Oh,
You don't
good.
hear any problem in it.
Good.
So I think the main problem, like we spent like as you as you said, it's a pattern recognition. So it's very important for me, especially if you are working alone.
Hmm.
You need while you are going down and you want to reach to a specific place, you need
Hmm.
to hear how the
Yeah.
noise level and the spiking is changing.
Hmm.
Um, so you don't want to just keep looking to the screen, and most of the time you are more careful about going with
Oh
the
my gosh.
electrode so it does not bend
Especially
or something.
down in the brainstem too, because there's so many
Yes.
there's so many sinuses down there.
Yeah, so you are very careful about the like you want to your eyes to be with the electrode and your
Hmm.
ears with the spiking, so you
Yeah.
reach to the
Yeah, it allows
uh
your focus to be in two different places. Both are very important.
yeah, so it was very interesting. It was very interesting. I think that the Radiant software is very interesting. Like I
Mhm.
like it. I
Good.
like it. I keep sending Dylan and about more stuff that can be
Hmm.
included. I think this
Yeah.
will be very, very interesting.
Hmm.
Um,
So
yeah,
can you explain to me, so what how, I guess when you joined the lab, they already had Radians?
no, no,
Okay.
no.
Okay.
So it's purely okay. So the reason I like looked into XDAC1 is because the reason that I needed a system which is money-wise is good,
Hmm.
like it's not that expensive, but also it has a combination of stimulation,
Yeah.
recording,
Hmm.
and
Hmm.
it can be extended to NeuroPixel if I needed it at some
Yeah.
point.
Yeah.
So in all of these collection of features, you cannot find it in most of like if you search for OpenEFS, it's only recording. If you
Hmm.
look into the Intan hardware, it's either recording or stimulation. Cannot have both. If
Hmm.
you look into Neuralangs and like it's only also like they have stimulation and recording, but you don't have an extension for NeuroPixel, I guess. So there
Hmm.
is there is like a limitation on many things. I think XDAC one was a very good choice because it can be extended to NeuroPixel. It has the
Hmm.
stimulation, it has, and then the Radiance software, it is very user friendly, that's for sure. And I thought that's a good thing to start like using. I like the online features of spike sorting
Hmm.
and like having like being able to see each neuron independently and the
Yeah.
fine grade. That's good.
Yeah.
I have suggested like some more features which we need when we are doing opto tagging. We need to see
Hmm.
whether this neuron is responding or not very quickly while you are online. I think this is like something that most people, okay, we can do post hoc analysis and see whether we opto tagged the neurons or not. But if there
Yeah.
is a feature, okay, you can just pop up like this neuron and see the firing rate, the
Yeah.
like
Can
histograms
you,
of changing.
I guess maybe you can educate me. How would you see the activity of a neuron that you've optotagged? Like, how would you know, like, okay, unit number, whatever on this channel? Like how would you be able to?
Increasing or decreasing in the firing rate after locked to the stimulus, right?
Okay. Yeah. Yeah.
So you just need to lock everything to the stimulus and then look to the distribution of firing rate before and after. I think I think in the software you guys have everything. It just need this like lock it to a stimulus and then look to the distribution of firing before and after.
Yeah. I'm thinking that probably would be an easy thing for them to put in there because I know that in the offline sorter there's some like stimulus locking. So I feel like that would be really easy to put in the online version. But wow, I've never thought about that, but that would be a really cool application.
I think most of the experiments that people are doing in the lab right now, or the one that we initially build the setup immediately for it, and that's why I was trying to finish everything before I leave to Brown, was basically having this opto tagging of specific population within the deep cerebellar nuclei and stuff like this. And this can only, if you want to see it while you are doing, you want to stimulate and see.
Yeah.
So that was one of the things. So no, they didn't in the lab when I came. They mostly was using Intan, and there is one rig for NeuroPixel, and there is another rig for OpenEFIS, and all of them are distributed. So I think and they don't have any stimulation like system for. So I think when I started the putting the rig together, that was the only system that probably have the potential like to include everything, which is very great if you are building your own setup. That would be a very great on the long run. Yeah.
Okay, neat. And so that pushed you to get Radiens. I'm sure that you've seen in Radiens, but there is an option where you can set specificity to like what Headstage you're using and what probes you're using. And I always think that that's really interesting, especially if you're using NeuroNexus probes. Can you tell me a little bit about the I guess the structural layout of the hypoglossal nucleus? What type of probe are you using, the like geometric layout of it? And how did you decide that for this region?
For the hypoglossal, the plan was always like that we try to use flexible probes. And the flexible probes were custom designed from some collaboration lab in UCSD. And we are doing some also collaboration. It's like we purchased some flexible probes from Atlas Neuro, which are very flexible. Like they are 5 micron thickness. So they are very flexible. And the arrangement of the electrodes, like usually we determine it based on the dimension of the hypoglossal. It's like 1 millimeter by 500. It's a big nucleus extended from dorsoventral and from rostrocaudal. So yeah, I think we initially we wanted to use the 3-channel, 3 columns with like 32 channel. That was the best design that we were thinking of using initially.
So kind of like a long and skinny, just like
like they have like 3 channel and then it's 3 columns, and in each column there are 32/3. Like there are I think like 8 and then 8 or something like this. So
okay. So 32 channels in total across the 3 shanks.
It's only not 3 shank. It's 3 column in a single shank.
Whoa. Okay.
3 columns of electrode. This is 32 channel single probe, like single shank electrode, like a single shank probe. It's nothing. It's a very regular one. We thought about using the flexible, the multi shank one, but this is still very far ahead from. Like once we establish first that we can record with single shank in a brainstem, which is flexible, then we can go step by step to a higher number. And making these electrodes are not very easy. Flexible probes are not very easy to make. So
I've heard.
So that was your question, right? So So the hypoglossal, like this is like the long shot if we manage to do this in free moving animal, because the main idea is to do it in free moving, not in head fixed. So
yeah, of course, that's like the gold standard for any behavioral paradigm that you're looking at. So yeah. Okay, neat. So this GUI that you developed.
So the main problem when you guys like send the stuff, I thought like I will find all types of probes and it can be added very quickly, right? And that was not the case. Like you have to, I think you guys told me that I have to send you what kind of probe, the geometry, and then you do some Excel sheet or a PRB file, .prb extension, and then you send it to me to add it to the Radiens devices like slash path. And this was not gonna work because I told you we are using a lot of different probes, and also we are using different adapters. So sometimes I'm using an adapter from Atlas, someone else is using an adapter from Cambridge, and someone else is using an adapter from BlackRock. So we have like everyone is bringing sometimes his adapter and stuff. So it's just not gonna work.
You use what you can when it's available. I get that.
Yeah. So like I tried to understand how this is done. Like I think it's very simple. Just generating the CSV file was I was not like getting how to make the Headstage conversions and all of this. But I think like I understand a bit right now how to make it nicely. And I think just making the electrode configuration, the GUI is very trivial. It's very like it's nothing major. It's just like basically I can show you quickly.
Yeah, please. And you did all of this in MATLAB, yes?
Yeah, that's the easiest for me.
Okay. Yeah,
because
I love
I can
MATLAB.
do it.
Yeah. Did you have experience in MATLAB before this?
Oh yeah, I have been doing MATLAB since I was
He says, yeah, I know MATLAB. Okay, cool, very cool.
No, I just so can you see so let me describe to you. This is the GUI when you initialize it. Like it shows you chunk width, chunk length, apex depth, which is this point, and then number of rows and columns, and row pitch and column pitch. And these are inputs that you can find in any, like it's very easy to get it from any probe. And for example, I have 100 micron. So so the scaling like sometimes does not get nice, but you can see now everything, right?
Yeah, I can.
Okay. So now you can just increase the width, the length, you can make it 400, just increase it, and you can see the 0 point is at the tip, and the 400 is the base. And then you can say, okay, the apex depth can be 50, but it can be also 20, which is more shallow. It can be very sharp, like 70.
Yeah. Wow. So this is like super customizable, and you can just make
you can make, so now if you want to make 4 columns, you can just get 4 columns. Okay. It looks a bit weird because I did this, but now it looks okay, right? So you have 4 columns, and in each column you have electrode number here. You can see these are masks, so you can switch off. For example, if you look, I can switch off this, and I have only 2 here. You can switch off all this column, and then it resize everything.
Yeah.
So, and then you have the number of rows. In this case, you have 10 rows. And sometimes you don't need to fit you can just organize the electrodes or fit it to the chunk length, so it occupy the whole chunk or part of the chunk. And you can change the shape of the and the diameter.
Very cool.
So you can make it 10 just to see it. And then if you want the pitch between the rows are only like, let's make it only 10. So if it is 50, 50 is too much. You can 25, you can increase to 30. and it can increase to 35 maybe. Yeah. Okay. And then the column pitch is the distance between column. You can make it 14. You can make it whatever, as long as it is within. I think usually like if you have the inputs right from the manufacturer of the electrode, it should work perfectly fine.
Yeah. Okay, so you essentially go in, you can build out your probe based on the specific dimensions that you have. And then from this, is this something that you can use in real time while you're acquiring data?
So what happens, this is the main idea, that you generate a CSV file, and then from the CSV file you run executable that generate PRB, and this is basically, I think Aaron sent me this very small, it's like a small executable file that you can just run and generate a PRB, and then you take this PRB file and you put it in Radiens, and then you don't need to ask you guys for generating the probe geometry. So it is already now included in the software that you guys have. That you, for example, if I have a geometry which is okay, I'm shifting this 10 column and I'm shifting this column by 5. Okay, you see this basically small shift that happens, and I have the numbering of electrodes slightly different. So in this one, for example, this is not 2, this is 20. Because in most of the probes, you find that the numbering system is changing, right?
Yeah, the channel mapping is not.
Channel mapping is it. Okay, so you can do this. And then you can go through and you rename and re-ID everything. And now you have a probe which tells you the site of each. You get so if this is the end, I do export CSV and then go to this. Yes, let's make a new folder, geometry.
And then so you've done this, imported your probe into a Lego, and it works in Radiens?
Yeah.
Awesome.
I exported this. So all you need after this, all you need of this then is to, this is a small, I need to fix this maybe, but you just basically remove the first 4 columns and you remove all the nuns. You can just delete these columns. And just delete this rows. I think that's it. And then you have this is the CSV file that basically have the site number. So site number 1, where it is exactly, and site number 20 where, and so on and so forth. And then you save this, and then you go to the executable, which is basically, you can go to this, for example, and then you can see here there's CSV to sensor Darwin arm 64. This was sent by you guys. And then all I need to do is just like .csv sensor draw arm, the program, or the executable file, and then I want to make a probe, and the output directory is Atlas probe geometry, for example. And then once you press X, it will generate a BRB file, which then you take this BRB file and put it in your Radiens path.
Yeah. Wow.
So it's nothing. It's just to ease my life. That's all.
No, this is awesome. And I know you're saying like it's not that complex, but this is super cool. And I feel like really important, especially like you said, if you're using a variety of different probes or trying to figure out what works well for you.
With Radiens, especially with Radiens software, because I think Radiens has a lot of option inside. Like, so from NeuroNexus, you will find a lot of option, but from other, you don't see. And then the Headstage one was this one, which basically, okay, so I'm using acute preparation sometimes. You hit fixed the mice, and then we insert the probe. And for this, we need an adapter, and this adapter changes, like it has this Semtech connector, and this Semtech connector has female and male, and then the bin mapping between male to female. So first, you have the site to the male connector on the probe itself. And then you have the male connector has to go to the female connector on the adapter, and this has another mapping. And then the FOC has a different connection to omnetics, and then the omnetics have actually connection to the native channels on the Headstage amplifier. And you need to go through these, like basically to say, okay, which bin is connected to which site. So site number 1 electrode is connected to MOLC bin number 1. And then number 1 MOLC is connected to FOC pin number 3. And then it's just like a very stupid mapping, between the beginning of the site where it ends in the native channel.
Yeah,
and
but
it's
I mean,
just
like,
helpful for people like me who are
yeah.
like haven't used the electrophys for so long. So
Yeah, well, I mean, like all of this stuff is important to know exactly like where you're recording, so that can translate into the data that you're actually acquiring.
Exactly.
And being able to map that. So okay, so there's two user interfaces. There's one for the probe and then one for the Headstage.
Yeah, so you generate also Excel sheet, and then when you are running the executable, in this case, where is it? Yeah. In this case, the executable would be, instead of writing probe, you write Headstage, and then the output directory is the same where you want to use. So generally speaking, like it's and you can choose. I think I didn't play around in this so much because I'm using only 32 channel probes right now. But you can also have because every Headstage has slightly different bin connection between the native channel and the omnitic bin. So you need to change these like mapping by what you think is right. So you can also enable and disable. So it is very it's very straightforward. And if you are using 64 channel, you will have to go through the 64 channels.
I'm trying to think, could someone set this up with like a high density probe, like a Synapse or NeuroPixels? Like if they wanted to do like 128 channels, would there be a way for them to add this, or does it?
I have no idea. My main idea, I think this is maybe very suitable for INTAN head stages. For the probe geometry, I think you can do any types of probes. At least I tested many. So, but I think NeuroPixel has its own mapping, and they have a lot of nice functionalities in it. I haven't used it, to be honest, so I don't know.
Yeah, I guess I'm just thinking for Radiens, because our X stack has capabilities to use NeuroPixels, but as of right now, Radiens doesn't have NeuroPixels compatibility. We have Synapse, but so
So right now I'm not using NeuroPixel, and I don't think I will need to use it immediately. But it could be interesting to see Radiens extending to this. I think Radiens user interface is very, very nice. Just the small, the small things that like they just made things. I think it just need a bigger user base. That's all. That's all. So it will correct many things very quickly, and users can add many things very quickly in it.
Yeah, that's one thing that I'm excited about to see. I think the Radiens is really streamlined, but then also thinking about NeuroNexus has been creating silicon probes for the past 20 years, and Radiens is only about 2 years old. So like for not being that old, it's already so good. And the developers are so like, they're really down to earth. They're really excited about new ideas. And so
I love Dylan and Aaron. They are very, very, very helpful. And their response time is like perfect. They can respond very quickly, and I'm happy that I'm giving them feedback, and I would be happy to, once we start doing more stuff, I will send more feedback. I hope they don't hate me.
No, that would be perfect. And then so I saw that you already put this up on MATLab's file exchange. So you're happy to share the code. And then do you have this on like a GitHub or something?
No, it's only one. It does not need like this was like a 2 days, like I was just trying to finalize everything, so it makes it easier for us because I was sending you guys a lot of emails like, oh, let's do, what about this? Can you send this other electrode?
Yeah.
And in the lab, there were two people waiting to use different types of probes with different adapters. And I felt like it would be like crazy if we keep asking.
Yeah,
So,
no, I think that was a really smart workaround.
yeah,
Really nice job on it.
Yeah, and I think the CSV to sensor executable was also part of the. I didn't add it in the MATLAB, but you guys, if you want me to add it to the file exchange, I can add it. And you can provide like if I haven't tested deeply the program, but it works fine, at least for what I used it for, like two types of two geometry and two different head stages. It works perfectly. So
yeah,
I don't know. Let's see.
Yeah, I mean, like if it works well enough for you, then yeah, it's awesome from what I see. It looks really good. Good job.
Thank you.
Cool.
Thank you. That's
Cool.
yeah. If anything you guys want anything, just let me know. I will be more than happy to help. And thank you again for the amazing, like being so nice and so receptive to all the ideas.
Yeah, no, it's just it sounded like you were doing something that was really interesting. I mean, like as a researcher, you have to get creative, right? Like you're asking these really complex questions and the technology that you're using, it's also complex, but it's like, what if I just did it in a different way? Scientists are definitely coming up with things that companies might be missing because they don't have the same demands that a postdoc has. So
yeah, it would be very nice if everything is very easy from this side, so I can focus on other things. But if if there is a suggestion box where you can just people keep adding ideas like how to improve, and you can add these features step by step, that would be great. There should be a way that you guys provide so even users, how many people are using, do you know?
I want to say
The user base?
it's like I want to say somewhere around 150, but not quite 200.
Okay.
So
So I think like if you guys need to make these people talk to each other, it will save a lot. It will save a lot of time for you.
Well, I think so, and then I think that would also just kind of accelerate its development because, you know, from our side there we have so many ideas of like different features that we can add, but at the end of the day, like we could just be coming up with some unnecessary things that like no one's going to use, but there could be a glaring obvious feature that we need that we don't know about. So just trying to like create a space for people to talk about it openly and honestly is going to be important.
Yeah, and it's not just about talking about it. Like there are some features, like if the software is not highlighting it, sometimes it can get like it goes with the wind, right? So user cases where, oh, this is a very nice feature and it helped the researcher to do this particular point, that would be very useful. There's a lot of cool things you guys can do. I'm sure that you thought about all of them.
Yeah, I'm excited. There's going to be a lot of stuff coming up, but also because you had mentioned that Radiens, it's not an open access software, but I think with the MATLAB and Python APIs, all of that can be really open source and shareable. And so I think like having the file exchange and being able to talk about kind of what people are doing, how they're getting creative, that is a really ripe path for growth for NeuroNexus, but also like for the people that are using Radiens.
The request is just to put people who are using Radiens together. I actually know only one person who recommended me to join the XDAG because when I was trying to buy the program, I didn't know anyone. I think she's gonna talk actually, and she's gonna give the talk. Katrina.
Yeah, she's
I love
awesome.
her.
Yeah, me too.
Yeah. So she's very good. She's a good friend. I never met her, but we worked in the same master lab. When I was in the master's, she joined later to do her PhD in the same lab. So
very cool.
But she's very nice. She's the one who recommended XDAG. So
she's really knowledgeable too, about all of it. She's great. Cool. Well, thank you so much for taking the time. This was really interesting, really cool. Like it's such a nice thing.
Yeah, it's good to see you, and it is very nice. I think Dylan and Aaron, they helped a lot. So whatever they will ask, I will definitely try to help.
Awesome. Cool. Okay, well, you enjoy the rest of your day, and I guess I'll talk to you later.
Yeah, good luck for the new job, and I'm sure that you will rock it.
You too. I can't wait to see how your research unfolds.
Me too.
Okay. Talk to you later.
Bye-bye.
Bye.
All right, everyone. That is the end of today's episode. Thank you so much for tuning in. We've linked today's guest in the show notes, so please go check them out. They're doing truly incredible work. You'll also find a list of the NeuroNexus products they used in their research, which we hope is helpful whether you're setting up a lab or optimizing your current workflow. This show wouldn't be nearly as interesting without the researchers who join us. If you're using NeuroNexus products and want to showcase your work, we'd love to feature you through a full episode, a short spotlight, or simply sharing your research with the community. You'll find a showcase submission form link below, so go ahead and fill that out. If you found this episode interesting, make sure you're subscribed so you never miss a conversation. We're actively building connections within the electrophysiology community, so come join us on LinkedIn, X, Blue Sky, Reddit, and Instagram. This podcast is powered by NeuroNexus Technologies, advancing electrophysiology at every step. We'll see you next time.